So we're going to talk today about a strategy to compare two fractions when we have denominators that aren't the same. Now, you might already be able to look at these two fractions and be able to tell which is bigger. By looking at the denominator, you'll notice that here we have a denominator of 2, here we have a denominator of 8, and our numerators in this case are both 1. So these are both unit fractions. We notice the first fraction, 1/2, it only takes 2 pieces to make a whole, but in the second fraction, it takes 8 pieces to make a whole. The reason it takes more pieces in this fraction is because these pieces are significantly smaller. They're actually 4 times smaller than 1/2. That tells me then that 1/2 is much bigger, and 1/8 is much less than half because it would take 4/8 in order to make 1/2. Now, we can see the same thing here by looking at some of these fractional pieces. So if I had the first one, let's put a half. And then in the second one, I'm going to put an eighth. Just visually, you should be able to see that 1/8 is significantly less than 1/2. And again, it's because it's split into more pieces. We might even be able to see here that if I add in more eighths, it's going to take 4/8 in order to make the same as 1/2. And those two things would be the same. Now, we want to be able to use this in our fraction form as well. How can we make this happen? Well, one way is we can use a strategy called making common denominators. Now, when you're making a common denominator, most people start with a table where they look at both of their denominators and they try to find multiples of their denominators until they find one that is the same. This is a process looking for the least common multiple. That means, what is the multiple between these two numbers that is the smallest and the same, the thing that is in common? So I'm going to write down a few for 2. So I'm going to count by 2s, 2, 4, 6, 8. And then I'm going to write down some from 8, and you'll notice that the first multiple of 8 is a match. This tells me that our common denominator between 1/2 and 1/8 is 8. Now, when we do this, all we're doing is we're taking this number and we're making an equivalent fraction to 1/2 that has an 8 in the denominator. Here's how I'm going to do it. I'm going to write an equal sign, and I know my denominator, I want it to be an 8. Now, in order for my denominator to be an 8, I'm thinking, what am I doing to that 2 in the denominator? Well, I'm going to multiply it by 4. Remember earlier I told you that 1/2 is 4 times as big as 1/8? That's why we're multiplying it by 4. And whatever I do to my denominator, I have to do the same to my numerator. If I don't do the same to each, then I am not coming up with an equivalent fraction. Multiply that by 4, and you'll notice that we get 4/8, which is exactly what we saw with our blocks here, that 1/2 is the same as 4/8. Now, the nice thing about a common denominator is that now when we have common denominators, you'll notice it becomes significantly easier to say, well, which of these is bigger, 4/8 or 1/8? 4/8 is obviously bigger. All right, let's see if we can look at another example. What about 3/4 and 2/3? Now, a couple of things you might notice about these numbers. The first thing you might notice is that they don't have the same denominator. Here we have a 4, here we have a 3. We notice that fourths, hopefully you notice, that if this was just 1/4 and 1/3, it would be much easier to compare because thirds would be split into less pieces, so they would be bigger pieces, which they are. And notice here we have a 1 in each. This would just be saying one of those thirds or one of those fourths. A third would be bigger. The thing that complicates this a little bit is that the numerator is also different. The numerator is also not the same in each of these pieces. Now, one thing you might notice that is in common is actually each of these are only missing one piece from being a whole. So for example, 3/4 needs 4/4 to make a whole, but it only has 3. Just needs one more fourth. 2/3 needs 3/3 to make a whole, but it only has 2. It just needs one more third. So they're each missing one piece from being a whole. Now, let's see what these look like when we represent them here. Let me take away my pieces that we were using before. And we will make this time, we're going to represent first, let's represent 3/4. So here's what 3/4 looks like. And then on the other side, I'm going to represent 2/3. Now, you should notice right off the bat that a third we can visually see is bigger than a fourth, which we already predicted and we already said. And you may even realize by looking at this visually that 3/4 is actually bigger than 2/3. Now, the reason that's true is because you'll notice both of them are missing one piece. But the one piece that a third is missing is bigger. It's missing a larger piece. That means it's further away from being a whole. Versus 1/4 is missing a smaller piece. It's closer to being a whole. It's a closer piece. Now, how could we see this in fraction form? Well, we could use the same idea by making common denominators. Just like we did before, if you make a fraction table, and you write down both of your denominators. I'm going to count by each of these numbers. So 4, 8, 12, 3, 6, 9, 12. There's my least common multiple, the smallest multiple that they have in common. So I'm going to change each of these into 12ths to come up with equivalent fractions. Same idea as before. I'm going to ask myself, what times 4 is 12? That would be 3. So I'm going to do the same thing to the numerator. 3 times 3 is 9. 3/4 is the same as 9/12. Now, if you don't believe me there, I can prove it to you. This is 3/4. If you want to see that it is the same, let me bring out some 12s. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you'll notice that 3/4 is indeed equal to 9/12. Those two things are exactly the same. It takes more 12ths because they're smaller pieces. In the same way, you can do the same to 2/3. 3 times what is 12? Well, that's going to be times 4. 2 times 4 gives me 8/12. And I promise, and if you can check me on it if you don't think so, that 2/3 is the same as 8/12. Now, what we've done here, again, is we've made it easier to compare. Now we can easily see that 9/12 is bigger than 8/12. Therefore, 3/4 must be bigger than 2/3. So common denominators can be a really helpful way in order to compare two fractions to see which fraction is larger.